Welcome to solverfy.
Let's get a visual of this triangle. Don't worry about it being to scale, but we've got one side that's 24.1, another that's 12.8, and a third that's 19.4. We want to know what the angles at the corners are. So I'm going to call the angle away from the 24.1 angle A. The one away from 12.8 angle B and angle C. Okay, so we can first find the angle across from 24.1 using the law of cosines, which in general is the following. That's the generic one. But if we're going to find angle A with this, we want to anchor the formula with the 24.1. So the side, and then this will be the cosine of that angle. I'll capitalize them appropriately. And so the A and the B in this case would actually be just the other two sides, which are 19.4 and 12.8. Okay, so what we'll want to do is subtract 12.8 squared and 19.4 squared. Then they're to the left-hand side, and then we'll divide, because that's all one product that's left now, by the negative 2 times 12.8 times 19.4, and that will be equal to the cosine of A. But then we want to take the inverse cosine of each side, and that will leave just the measure of angle A. So to a calculator we go in degree mode, the inverse cosine of 24.1 squared, subtract 12.8 squared and 19.4 squared, and then we'll want to divide that by negative 2 times 12.8 times 19.4. And we get 94, nearest 10th, 94.7 degrees. Now we can use the law of sine since we have a pair. To go for angle B, we can say that the sine of angle B over its opposite side, 12.8, is equal to the sine of 94.7 degrees over the 24.1 on the opposite side. Cross multiply the 12.8 and then take the inverse sine of both sides. Then you'll have just angle B equals the inverse sine of our ratio here. So the inverse sine of 12.8 sine 94.7 over 24.1 is to the nearest 10th, 32 degrees. And then the angle across from the 19.4, which is what I'm calling C, you can just subtract from 180. 180 degrees, subtract the 94.7 and the 32 that we found, leaving 53.3 degrees.